Welcome to Across the Globe. Today, we will learn about Object-Oriented Programming, OOP. Object-Oriented Programming, OOP, is a programming paradigm based on the concept of objects. These objects are instances of classes, which are user-defined data structures comprising attributes, data, and methods, behavior. OOP enables the modeling of real-world entities as objects and specifying their interactions. For example, a car class could include attributes like color and speed, along with methods like accelerate and brake. Through OOP, you can create objects representing specific cars with distinct color and speed values and invoke methods to modify their speeds accordingly. This paradigm enhances code organization and reusability by encapsulating data and behavior within objects. A class in object-oriented programming, OOP, serves as a template for the creation of objects with specific attributes and behaviors. Objects, in turn, are instances of classes that encapsulate data in attributes and carry out actions via methods. To illustrate, consider a class car, which could possess attributes such as color and model, along with methods like drive and stop. This structured approach enables the modeling of real-world entities, like different cars with unique characteristics, through the concept of classes and objects in OOP. Encapsulation in object-oriented programming refers to bundling data and methods within a class, essentially encapsulating them together. This process shields the internal workings of the class from external access, promoting a cleaner design and reducing potential interference with the data. Abstraction, on the other hand, entails simplifying the interaction with objects by providing a clear and simplified interface while hiding unnecessary complexities. It allows users to operate with objects by focusing on what needs to be done rather than how it is achieved. For instance, consider a bank account class with attributes like balance and methods like deposit. Encapsulation ensures that the balance data is protected and only accessible via defined methods like deposit. Abstraction, meanwhile, simplifies this interaction by allowing users to deposit funds without needing to know the intricacies of how it is handled internally. Inheritance in object-oriented programming enables a subclass to inherit properties and behaviors from a superclass. It promotes code reusability and structuring. For instance, a vehicle superclass might contain attributes and methods shared by car and motorcycle subclasses. Polymorphism refers to the capability of objects from different classes to be treated as instances of a shared superclass. It enhances flexibility and modularity in code. For example, a superclass animal could have subclasses such as dog, cat, and bird, with each implementing their unique behavior for a method like speak. The provided Python snippet demonstrates the concept of polymorphism. Both the dog and cat classes have a method named speak. Through polymorphism, instances of dog and cat can be treated as instances of a common superclass, enabling interchangeable behavior when calling the speak method on any instances of these classes. Object-oriented programming, OOP, is a paradigm that promotes the reuse of code through the concept of classes. Classes represent blueprints for objects that can be instantiated multiple times within a program, allowing for code reusability across various parts of the program. By organizing code into modular components, OOP enables developers to more easily maintain and update their programs. This structured approach helps in isolating different functionalities into separate modules, improving code maintainability and reducing the risk of introducing errors when making changes. Additionally, OOP allows for the modeling of complex systems in a more intuitive and structured manner. For example, in a banking application, different classes can represent customers, accounts, and transactions, making the overall system design more comprehensible and easier to manage. In conclusion, OOP not only promotes code reusability and organization, but also provides a clearer way to model and work with complex systems, making it a valuable tool for efficient software development. OOP is like building a house with Lego blocks. Each Lego block represents a class in programming. Each block has its own specific function and can be connected to other blocks to build a larger structure. Just like how you can easily take apart and rearrange Lego blocks to create new structures, you can also reuse classes in OOP to build different programs with similar functionalities. Hey, code conquerors, ready to level up With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. When the above Python code is executed, it creates two Lego block instances, one red rectangular block and one blue square block. The getDescription method is then called on each block to display the description of each Lego block. Next, a Lego structure class is defined to represent a structure made of multiple Lego blocks. The class takes a list of blocks as input in its constructor. The getStructureDescription method is used to generate a description of the Lego structure by iterating over each block in the structure and getting its description using the getDescription method from the Lego block class. Finally, a Lego structure is created using the previously defined red and blue Lego blocks. The getStructureDescription method is called on the Lego structure instance, and the description of the structure, including the description of each block within it, is displayed. This code example illustrates the concept of OOP by encapsulating related data and behavior within classes, Lego block, and Lego structure, and demonstrating how objects can interact with each other to create complex systems, similar to how real-world applications are built using OOP principles. One industrial example of object-oriented programming, OOP, is in video game development. In game development, OOP is widely used to represent game entities, behaviors, and interactions. For instance, in a game like World of Warcraft, different classes like player characters, NPCs, enemies, weapons, and items are represented as objects with attributes and methods. The inheritance and polymorphism features of OOP allow for efficient management and organization of game elements, making it easier to add new features or modify existing ones without affecting the entire codebase. Another application of OOP is in the development of web applications. Frameworks like Django and Ruby on Rails leverage OOP principles to create scalable and maintainable web applications. Classes and objects are used to represent different components of the web application, such as models, views, controllers, and templates. This modular approach simplifies the development process, improves code readability, and allows for seamless integration of new features or updates. In conclusion, object-oriented programming, OOP, provides a powerful and versatile framework for designing and implementing complex systems in various industries and real-world applications. Its ability to model real-world entities as objects with attributes and behaviors makes it an indispensable tool for software development across the globe. Keep learning, stay curious, and I'll catch you in the next video.